use a lot of the same process that you do to solve a quadratic equation. You're going to get a 0 on one side. You're going to factor the other side. But there's a little bit more involved in terms of after that than solving an equation. So the way you're going to solve a polynomial inequality, and again, when I say a polynomial, we're talking about an inequality that is the second degree or higher. So in other words, you're no longer dealing with just to the first power. So the way you're going to solve these is you're going to write the inequality so that your polynomial is on the left and 0 is on the right. So the setup is very similar to an equation, but you want to make sure that 0 is on the right-hand side. So in other words, you want the inequality in this form. F of x is greater than 0, or you could have f of x is greater than or equal to 0. F of x is less than 0, or f of x is less than or equal to 0. So the step number one is you want to get it in this format. Just like solving an equation, what you're going to do is you're going to factor the left-hand side. And you're going to determine the values on the left side which equal 0. And if it was an equation, you were done. You'd set each factor equal to 0, boom, you were done. But this is not an equation, this is an inequality. We don't call these your solutions because they're inequalities. These are called your critical numbers. What you're going to do is take these numbers and you're going to plot them on the real number line. And what happens is when you plot them on the real number line, you're dividing your number line into intervals. So for example, if you plot 2 of them, notice you end up with 1, 2, 3 intervals on your number line. So notice if you plot these values on your number line, you have numbers less than this one, numbers between the 2 critical numbers, and numbers greater than the largest one. So you see your number line will be divided. You're always going to have one more interval than the number of critical numbers. So if you have 2 critical numbers, you'd have 3 intervals. If you had 3 critical numbers, you would have 4. And what we're going to do is we're going to pick a test number in each interval and substitute it into the factored expression. You're going to determine the sign. Is it a positive or negative? You don't need to find the exact number. All I want to know is because I'm doing a comparison to 0, what kind of numbers are greater than 0, positive or negative? Positive. So all I need to do is know in these intervals what's happening. If I plug it into my equation, my factored form, would it give me a positive number or a negative number? That's how we'll determine which interval is going to be the solution. So if the value of f is positive, then it will be solutions for f of x greater than 0, because positive numbers are greater than 0. And if one number is positive in that interval, they all will be. So that's why you only have to pick one number. So if one number is positive in this interval, they all are. If the value of f is negative, then that means it has to be less than 0. So if one number is negative in the interval, they all are negative. So if you're trying to solve an inequality that's less than 0, you're looking for the intervals that would produce negative numbers to be solutions. You are going to write your answer in interval notation using parentheses, remember, for the less than or greater than, and using brackets for your greater than or equal to. So I will be requiring you to use interval notation. Remember, if you're dealing with infinity, it's always a parenthesis if it's coming from negative infinity, or if you have some interval to positive infinity. Remember, you always put parentheses before negative infinity or parentheses after infinity if you're using interval notation. So let's take a look at how we're going to solve these. Let's take a look at number 1. X squared plus 8x is greater than 0. I already have the 0 on the right-hand side. So how am I going to factor the left? What can I do? I can take out a what? X. So I can take out an x, and that's going to give me x plus 8 is greater than 0. Now I'm going to set each factor equal to 0. So because you have a x here, you have to take x and set it equal to 0. X plus 8 equals 0. So then what are your critical numbers going to be? Your critical numbers will be what? 0 and negative 8. So these are the values you're going to plot on the real number line. So again, make sure you do smallest to largest. So again, negative 8 I know is smaller than 0. Now this is where you have to decide, are we going to include negative 8 and 0 in the solution set? So this is very similar to what you did to solve a linear inequality. If this is greater than, what kind of circles go in my real number line, open or closed? Open, because we're not including. So I know those are going to be open. So notice, how many intervals is my number line divided into? 3. I've got numbers less than negative 8. I've got numbers between negative 8 and 0. And then I've got numbers larger than 0. So I have to pick a test number in each interval. You never use one of the critical numbers. Always use a number in the interval. Any number, eeny, meeny, miny, mo, pick a number less than negative 8. So I'm going to pick negative 9. Could I pick negative 10? Yes. Could I pick negative 11? Yes. Could I pick negative 100? Yes. Any number less than negative 8. If one of them is positive or negative, they all are less than negative 8. So now what you want to do is plug negative 9. The easiest form to plug it into is the factored form. So I don't need to know what the actual number is. I just need to know, would the resulting number be a positive or a negative? Well, if I plug negative 9 in for x, that gives me negative 9 times. What is negative 9 plus 8? Would that be a positive number or a negative number? Negative. So what happens when I multiply a negative 9 times a negative number? Would that give me a positive number or a negative number? Positive. Now look at your inequality sign. It's greater than 0. What kind of numbers are greater than 0? Are they positive or negative? Negative. No. Greater than 0 is what? Positive. So what I'm doing is I want to know the positive intervals are going to be the solutions to this particular inequality. So what I know right now is that my numbers less than negative 8 are going to produce a solution. That works, because that's positive. Now, you want to pick a number between negative 8 and 0. So the easiest numbers to work with are 1, 0s, and negative 1. So I'm just going to use negative 1. Plug negative 1 into the factored form. So I have negative 1 times negative 1 plus 8. What kind of number would that produce? Well, negative 1 plus 8 would be a positive number, correct? So that's a positive times a negative. So when I multiply a positive times a negative, what's going to happen between negative 8 and 0? Are they positive numbers or negative numbers? Negative. So would I have solutions between negative 8 and 0? No. So now I need to pick a number larger than 0. I'm going to go ahead and pick 1. Plug 1 in. Well, 1 is positive. 1 plus 8 is positive. So a positive times a positive would produce what? Positive. So again, remember, I'm looking for positive intervals, so I have another interval that will produce positive answers. So I know there's 2 intervals that will be solutions to this inequality. So any questions on the number line test? Yes?
How do you display your answer?
We're going to write it in interval notation.
Oh, okay.
Yep. So again, we're going to write the answers in interval notation. So I have 2 intervals I'm going to have to write. I need to write numbers less than negative 8. So again, remember, in interval notation, it's going to be negative infinity to negative 8. Am I going to put a parenthesis or bracket after negative 8? Parenthesis. And then I need to write an interval for numbers greater than 0. Am I going to put a parenthesis or bracket before 0? Parenthesis. So it's going to be 0 to infinity. So from your number line, that's just a test you're doing, your answers need to be written in interval notation.
Is the number line part of the answer?
No. It's part of your work, yeah, but because it's justifying where you're getting these answers from. Any questions on the first one? So let's take a look at the second one. First of all, what number do I need to have on the right-hand side? I need to have a what? 0. So I'm going to have to do what to get a 0 on the right-hand side? I'm going to do what? Add 12. So now I need to factor the left-hand side. So factors of 12 that add together give you 7. X plus 4 and x plus 3. So I need to set each factor equal to 0. So x plus 4 equals 0. X plus 3 equals 0. Remember, these are not my solutions. These are my critical numbers. So what are my critical numbers going to be? Negative 4 and negative 3. Okay? So any questions on that? So now I'm going to plot negative 4 and negative 3 on my number line. So now this is a less than or equal to. So tell me, less than 0. What kind of numbers am I looking for to be my solution? Are they going to be the positive numbers or the negative numbers? Negative. So I'm going to be looking for negative intervals. The negative will have my solution. Now it's less than or equal to 0. So what kind of dots am I going to put above -4 and -3? Closed or open? Closed. Because I'm going to include -4 and -3 in my solution set. Because that's where it's exactly equal to 0. So any questions on how I set up my number line? So just like I did before, I need to pick a number in each interval. I've got 3 intervals. Numbers less than -4, so I'm going to pick just -5. And again, plug it into the factored form. That's the easiest one to work with. Well, when I plug in -5 plus 4, is -5 plus 4 a positive number or a negative number? Negative. So it's a negative. Times -5 plus 3. Is that a positive or a negative number? Negative. What happens when I multiply 2 negative numbers together? Would that give me a positive or a negative? Positive. Am I looking for positive intervals? No. So I know that I'm not going to have any solutions, that interval is not going to be a part of my solution set. Now this is why it's important to understand you don't need to have an exact number. Because notice I've got these critical numbers between -4 and -3. I'm going to have to pick a decimal. So I'm going to have to pick, let's say, -3.5. All you need to concern yourself with is, would it produce a positive or a negative number? When I plug -3.5, again, use your factored form. When I plug it in for x, -3.5 plus 4, would that be a positive number or a negative number when I add them? Positive. Times, when I plug -3.5 in for x, -3.5 plus 3, would that be positive or negative? Negative. So what happens with a positive number times a negative number? It's negative. Again, what am I looking for? I'm looking for negative intervals. So I know I'm going to have a solution set between -4 and -3. When I plug in a number larger than -3, I'm just going to use 0. 0 is the easiest number to work with. 0 is greater than -3. 0 plus 4 is positive. 0 plus 3 is positive. So I know this would also be positive. So there'd be no solutions in that interval. So any questions on how I did the number line test here? So where are my solutions then going to be? It's a very small solution set. It's going to be between -4 and -3. How am I going to start the interval? Is it going to be a bracket or a parenthesis? Bracket. So I bracket -4, and then it's going to be -3, and do I put a bracket or parenthesis after -3? Bracket. So any questions on number 2? Let's take a look at number 3. X squared less than 9. First of all, what value do you have to have on the right-hand side? You have to have a what? 0. So I'm going to subtract 9 on both sides. How do you factor x squared minus 9? That factors into what? X plus 3 and x minus 3. So what are your critical numbers going to be? Your critical numbers are going to be what? -3 and 3. Now, it's less than 0. Tell me, am I looking for positive intervals or negative intervals? Negative. So I always like to know before I get started, what intervals am I looking for? Am I looking for positives or negatives? So now I'm going to do my number line test. Now it's less than, so am I going to do an open circle or a closed circle above -3 and 3? Open. You guys go ahead now and try the number line test and see if you can find. Again, you have 3. Pick your test number and see if you can come up with. So I came up with a very small solution set between -3 and 3. That's where I came up with my solutions. Any questions on how I came up with the negative between -3 and 3? So now what's it going to look like in interval notation? Am I going to start with a parenthesis or start with a bracket? Parenthesis, -3 to 3 and another parenthesis. So there's your solution. Now, some of you may say, well, wait a minute, there's a pattern that's going on. If the first one's positive, the next one has to be negative, that means the next one's positive. No. They're not all going to work like that. As you know in math, it does not take that long to pick a test number and plug it in. Don't be lazy. A lot of the times, yes, there may be a pattern where if this one starts positive, the next one will be negative, and then go to positive. That does occur. But there are instances where this could be positive, this could be positive, and that could be negative. So don't automatically assume that it's automatically those signs are going to alternate. That is the downfall of this. It really does not take that long to pick a number and plug it in and determine if it's positive or negative. Don't be lazy. All right? Because that's the one that probably will be on the test, and that'll be the one that bites you. All right? So make sure that you're testing a number in each interval. There are exceptions to this where that pattern doesn't always work. Okay? So any questions? But the number line test, just pick your number, and you'll get the right intervals all the time. Okay? What do you have to get on one side of the inequality first? You have to get a what? 0. So I'm going to have to subtract my 5x and subtract my 6. So 6x squared minus 5x minus 6 is less than or equal to 0. So now you guys go ahead and factor that and find your critical numbers for me. Make sure the numbers are in increasing order. Put them in smallest to largest. Obviously, we've got negative 2/3. We have 3/2. Now tell me, are we going to put open or closed circles above the critical numbers? Closed, because it's a less than or equal to. Now, what kind of numbers are we looking for to be solutions? Are we looking for positive intervals or negative intervals? Negative, because it's less than 0. So only negative numbers are less than 0. So now tell me a number less than negative 2/3. Negative 1. Negative 1 is a good test number to use. So when I plug negative 1 in here, I know that that's going to be negative 2 minus 3. That's a negative number. Negative 3 plus 2 would be another negative number. So a negative times a negative is going to give me a positive number. Remember, we already know we're looking for negatives, so there's going to be no solutions less than negative 2/3. What's a number between negative 2/3 and 3/2? What's a good one to use? 0. So I plug 0 in. 2 times 0 minus 3 is a negative number. 3 times 0 is 0. 0 plus 2 is a positive number. And what happens when I multiply a negative number times a positive number? It will give me what? Negative. So there's that negative interval I'm looking for. So I know I'm going to have solutions between negative 2/3 and 3/2. So what is a number greater than 3/2? A number greater than 3/2 would be what? 2. 2 times 2 is 4. 4 minus 3 is positive. 3 times 2 is 6. 6 plus 2 is positive. So that's going to be another positive interval. So no solutions there. So that because they're closed, I know I'm going to go from negative 2/3 to 3/2. Okay? So any questions, guys, on how you can solve the quadratic or the polynomial inequalities? All right, let's take a look at number 5. For some reason, I know you guys hate factoring when you see that x to the 4th. But you still want to get a 0 on one side, so we're going to subtract x squared. How do you factor that? Well, how do you always start factoring? You start by doing what? GCF. So the GCF I can take out as a what? X squared. And that's going to leave me with an x squared minus 1. Can you go any further with that x squared minus 1? Yes. So you can factor that into x plus 1 times x minus 1. So then what are the critical numbers going to be? How many are we going to have? 3. So we have 1 and negative 1. What else do we also have to consider? 0. So if you have 3 critical numbers, there's going to be 4 intervals. There's always one more interval than the critical numbers that you end up with. So when I plot these on my number line, negative 1, 0, and 1. Tell me what's going to happen at those 3 values. Are they going to be open or are they going to be closed? Open. So you can see your 4 intervals. Less than negative 1, between negative 1 and 0, between 0 and 1, and then 1 to infinity. So now again, remember, you're going to plug them into the factored form. Now, make life easier on yourself. When I plug numbers in for x squared, they're always going to be what? Positive or negative? Positive. So don't even waste your time. Don't plug a number into x squared. Just worry about plugging the values into x plus 1 and x minus 1. Because no matter what, this x squared will always be positive. So pick a number less than negative 1. I'll choose negative 2. So negative 2 plus 1 is negative. Negative 2 minus 1 is negative. What happens with a negative times a negative? That gives you a positive. Are you looking for positive intervals to be your solutions? Yes. So I know I've got solutions less than negative 1. Because again, you've got that greater than, so I know I'm looking for positive. Pick a number between negative 1 and 0. I'll pick negative 0.5. Well, negative 0.5 plus 1 is positive. Negative 0.5 minus 1 is negative. A positive times a negative will give me a negative. Pick a number between 0 and 1. I'll pick 0.5. 0.5 plus 1 is positive. 0.5 minus 1 is negative. Positive times a negative is a negative. There's that exception to the rule I was talking about. Notice you have two negative intervals right next to each other. All right? Now plug in a 2. 2 plus 1 is positive. 2 minus 1 is negative. That's a positive. So there's your, so like I said, there's that exception I said. Don't automatically assume you're going to get those alternating signs. So you have two intervals. You have numbers less than negative 1, and it's going to be a parenthesis after negative 1, and then numbers greater than 1. Okay? So any questions on that problem there? All right, if you can do a polynomial, you can do a rational inequality as well. It's the same number line test. Again, you still want to make sure you have a 0 on the right and your fraction is on the left. So you're going to set the right-hand side equal to 0. If you have more than one fraction, you want to make sure that you add and subtract fractions so that you can condense into a single fraction if necessary. So if you had 1 over x plus 2 minus 3 over x plus 2, you need to combine them to a single fraction. Factor your numerators and denominators if possible. To find your critical numbers, you set the numerator and denominator equal to 0. And you still do the number line test like you've been doing. But the way you find the critical numbers are different. Remember, can you ever have 0 in the denominator of a fraction and make it defined? No. So whenever you put the critical numbers from the denominator, they're never included in the solution set. The values from the denominator are always going to have open circles on the number line because you can never include them. That would give you a 0 in the denominator. The numerator values would follow the same procedure like we were doing for the quadratics. So, for example, take a look at number 7. X minus 3 over x plus 1. We already have a 0 on the right. Are we looking for positive intervals or negative intervals? Positive. So to find your critical numbers, you set the numerator and denominator equal to 0. So I'll set x minus 3 equal to 0. So what would the critical number be from the numerator? 3. I set the denominator equal to 0. What would the critical number be from the denominator? Negative 1. And I always circle that one. No matter what, this has to have an open circle because this is what would give me 0 in the denominator. So I always circle that critical number from the denominator as a reminder that that's going to have an open circle no matter what. So I'll do my number line test just like I did for the other ones. I'll plot negative 1 and I'll plot 3. No matter what, negative 1 is open. Now look at your inequality sign to decide what's going to happen at 3. I can be greater than or equal to 0. So what kind of circle would I put above 3? I would put a what? Closed. So with the fractions, it's possible that you're going to have some open and some closed. All right? Just remember, whatever comes from the denominator is always going to have an open circle. So now you do your number line test just like you did for the polynomials. What's a number less than negative 1? Negative 2. So when I plug negative 2 in for x, negative 2 minus 3 is going to give me a negative number on top. Negative 2 plus 1 will give me a negative number on the bottom. And what happens when I take a negative and divide it by a negative? That would give me a positive. So these are positive. And remember, you're looking for positive intervals. So I know I'm going to have solutions less than -1. Pick a number between -1 and 3. 0. 0 minus 3 on the top is negative. 0 plus 1 on the bottom is positive. A negative number divided by a positive number is going to give me a negative. So I know I'm not going to have solutions between -1 and 3. Number greater than 3 is 4. So 4 minus 3 is positive. 4 plus 1 is positive. So I am going to have solutions greater than 3. So then my solution's going to be from -infinity to -1, and then bracket 3 to infinity. So any questions on number 7, or how you do a fraction one? If you go to number 10, remember, you have to have your 0 on one side. If necessary, you have to factor the numerator and the denominator. So when I factor the numerator, what does that numerator factor into? It's going to factor into what? What's that top factor into? X minus 8 and x minus 1 over x minus 5. So if it's not already factored, if you can, make sure you factor the numerators and denominators. So now, to find your critical numbers. What's the critical numbers coming from the numerator? When I set the factors equal to 0, what are the critical numbers going to be? 8 and 1. What's the critical number from the bottom? The critical number from the bottom is a what? 5. And I'm going to circle that. Because remember, no matter what, this has to be open. Am I looking for positive numbers or negative numbers to be solutions? Negative. So I do my number line test. It's going to be 1, 5, and 8. 5, as we talked about, has to be open. What's going to happen at the other two? It's a less than or equal to. So the other ones would be what? Closed. And then you can do your number line test from there. All right? I want to do some graphs with you. Because like I said, not only do you have to be able to do these algebraically, you've also got to be able to do them from graphs. Okay? So let's take a look at a graph. Like I said, you've got different representations that you have to get comfortable with, not just the algebra, but the graphical approach. So here are two graphs. I've got a parabola and a line, and I want to know where is y1 greater than y2. So y1 is labeled as the parabola. So I'm just going to go ahead and I always like to highlight one of my graphs. Some of you will find this to be easier than others because you're more visual. You can still set up a number line if you need to. To find your critical numbers, if you're given a graph, they are points of intersection. So you still have to find your critical numbers, but they're going to be points of intersection between the two graphs. So right here and right here. So where is the parabola and line intersecting? They're intersecting at -2 and +2. Does everybody see that? So on my number line, I can plot my points of intersection. Just like we did with the algebra, you've got to decide, are these open or are these closed? Look at your inequality. It's got to be greater than. So are these going to be open or closed circles on the number line? Open. Now I want to know, where is y1, which is my parabola, greater than y2? So y1, remember, is the parabola. So one way you could look at this, those of you that are very visual, this will work for you. Where is the parabola above the line? You're comparing y values. So the y values on the parabola are above the line right here and right here. Notice this middle region between -2 and 2, the parabola falls below the line. So that can't have any of your solutions. If the visual part doesn't work for you, you can pick an x value, do a test number. You can pick a number less than -2 and look at -3. Actually, I'll go a little bit further because it's a little squished. I'll choose -6. So at -6, notice the y value is going to be 2. Notice the parabola is going to be, again, the graph goes all the way out here, remember. So notice, I know no matter what, the point on the parabola is going to have a y value much larger than 2. Does everybody agree with that? So therefore, that's why this is going to be a solution. Right here, if I pick a test number like it's 6, this has a y value of 8. It's not written, but I know the parabola will extend out to infinity like that. So the y value at 6 is much larger than it is on the line. So therefore, I know that has to be a solution as well. So I'm going to go from -infinity to -2, and then 2 to infinity. Like I said, some of you are going to have to pick the x and y values. Some of you are more visual, you won't need to. Let's take a look at number 12. Again, the critical numbers are the points of intersection. So your critical numbers are at -5 and 4. What kind of circles are going to go above -5 and 4? Closed. Everybody agree why they're closed? Okay. So now I want to know where is y1. And y1 is the line. Where is y1, since it's less than, where is that line below the parabola? So where is y1 less than the parabola? Well, notice, here's my line. The parabola is above the line right in here. So the line is below the parabola in this interval between -5 and 4. Notice my line right here is above the parabola right here. Same thing right here. So this is going to be from -5 to 4. Again, you're comparing the y value. So if you can't see it visually, pick points on the graph and compare them in each interval. All right? So your homework tonight, guys, is to do the